Good morning, girls. How are you? I hope you are all doing fine. Okay, before we start in our new lesson, I just need to revise the problems that was left for you to do yesterday, beginning with page 887, I think question 7 and 8. Yes, page 887, question 7 and 8. Okay, let's do it together. This was question 8. We were required to do a sequence of transformation on this triangle ABC. Select the image of triangle ABC after the given combination of transformation, reflection across the blue line, then 90-degree rotation around point P. I have to do two things. First of all, I have to reflect, and then I have to rotate, and I told you that order here is very important. Let's start by reflecting. Reflection, I should use what? A ruler. I'm going to go get a ruler, and then I have to put it straight and measure this distance. What is this distance? It's like 1 square. So counting 1 square from here, so B prime will be there. For C, it's a 1 square, so C prime will be there. And then for A, it's like 1, 2, 3. So 1, 2, 3 squares will be in here. So I will be having this. Which one? This shape. Yes, this will be B prime, this will be C prime, and this will be A prime in here. Okay, check. Yes, correct. Let's go to the second transformation. Step 1 is done. Let's do step 2. I need now to do a reflection of 90-degree for the new triangle. I told you before that when you have, sorry, not reflection, a rotation. When you are required to do a rotation, he has to give you 3 things. First of all, what is the center of rotation? And then what is the degree? And then what is the direction, right? Actually, he didn't specify a direction here. He should have specified. In the exam, it will not be left like this. The question should specify the direction, either clockwise or counterclockwise, because actually both of them can happen. In your books, clockwise cannot happen this easy, because the graph inside the book is very small. So it's only possible counterclockwise. But anyway, it should be specified in the question, either to go clockwise or counterclockwise. Okay, so let's say that the question was saying it's counterclockwise. I'm going to go get my protractor, and then, as we said before, the center on the center. And then I should draw lines, of course. I should begin by drawing a line. So for example, I want to start by rotating point B, the one in here, B prime. So get your ruler, draw a line from here to there. And then protractor, center on center. And then the line is on the line like this. The line that I drew is on the line of my protractor. And then I have to measure what? A 90-degree exactly. We have to measure a 90-degree exactly. Where is the 90-degree? It's like in here. It's like in here. So for example, this will be B prime, B double prime. B double prime will be in a place in here. What about C prime? Let's see. For C prime, measuring, this is like 90-degree, it will be there. So C prime will be there. So I have B prime here, C prime there. What about A? Let's see, what about A? A prime will be there. It's very easy here because it's a 90-degree. So I'm directly getting the 90-degree. Of course, my protractor, girls, is shrinking and enlarging. That's why I'm using it to measure the distance. But for you, you have to measure the distance using what? Ruler. And which I mean, after I find that the 90-degree should be in a place in here, I'm going to put a point and then remove my protractor and then connect these 2 points with a line. And then I have to measure the distance from here to here and copy it there. Yani 5 centimeter, يبقى 5 centimeter from here on the line, and then stick the point. So point A prime will be whatever. So for us, A prime, B prime, and C prime. Let's see Which one of them is the correct answer? It will be B. Beginning by B prime, C prime, A prime, and then A double prime, C double prime, B double prime. So it's going to be this shape. Check. Yes, correct. We did it correctly. So this will be your answer. This will be your answer. Okay. Next question. We had a triangle like this, GEF, and we were required to do 3 things today, or this time. Yeah. First of all, translation along vector V. And then 180 rotation. The 180 rotation is very easy, but you don't need any direction or anything. And then I have to translate again along vector U. Okay, let's start step by step. First of all, I have to do a translation along vector V. Let's count vector V. What's vector V? 1, 2, right? And 1 up. So each one should be beginning by F. 1, 2, and 1. So F prime will be there. What about E? 1, 2, and 1. So E prime will be there. So E prime, F prime will be there. يبقى I have to come and draw E prime and F prime. E prime, F prime. What about F G prime? Let's see, where is G? 1, 2, and 1. So FG will be there. FG will be there. And then what about EG? For EG, it should be like this. I think that try again. Yes, I'm sure. You know why? Because we didn't extend this this point here. We didn't extend this point. But anyway, just not to waste our time. Yeah, when you are doing the online thing, he is very, very specific that this point should be exactly in here. I didn't extend it, but you have to extend it, okay? After doing this, I know that this is E prime, this is G prime, and this is F prime. I'm required now to do what? I'm required to do a 180 degree around point P. Yes, so first of all, I have to begin connecting lines. And after connecting the lines, I have to use the what? The protractor. Beginning by F prime. I'm going to get this. I want to try to do it again very fast. Okay. Now I'm going to go get my protractor, put the center on the center of rotation, and then put the line on the line. Beginning by, I want, for example, to rotate F prime. So let's put like this. And then ask yourself, 180 degree means what? 180 degree means a complete protractor. Yani starting from here to here. Yani means that F prime, F double prime will be in a place in here. Where is the place? I have to go to get my ruler and measure this distance in here, from here to here. But this is like 1 square. So counting 1 square, so I will be having my point there. So this will be F double prime. F double prime will be there. Let's see, what about E double prime? Center on the center. Yes, we found it. Where is E prime? E prime will be there, exactly as if you are moving 180 degree and complete protractor. So starting from here, 180 full protractor. So it's going to be there. Why they're not there? Because I am using my protractor as a ruler. But this is the distance from here till here, so I'm copying it in the other side. So this will be E prime, E double prime. So E, F prime, F double prime was here and E double prime was there. We can draw it now. So E double prime, F double prime. Let's check. Where is G? Put the center on the center. And then go to G. The center, this G, sorry. This G. Yes, exactly. Where is G? Let's move a full protractor from here till here. So this is G double prime. So G double prime will be there. So it means that I can draw this line from here till here. And then yes, it was correct. Very good. And then I have to do the third step, which is, what was the third thing we should do? The third thing was, where is the question? Yes, we have to translate it along vector U. Yeah, let's do it. Translate it along vector U. Vector U is just going to the left. Very easy. Just 3 points to the left. So let's move. 1, 2, 3. So F triple prime will be there. Let's move. 1, 2, 3. So E triple prime will be there. So E triple prime, F triple prime will be from there to there. Right? Let's check. What about G? Let's move 1, 2, and 3. So G double prime will be there. So we can say that EG will be in here. And then for FG, it will be like this. Yes, very, very good. Excellent. We did it. Okay, understood? So this was question 7 and question 8. This was question 7 and question 8. If we see them in our teacher edition answer, it is the same answer as we did. This is question 7 as we did, and then this is question 8. Okay, let's go to this was the rigid transformation. I left for you the non-rigid transformation as well. You remember the dilation thing when you have to use the rule and start multiplying and these things. So it was again easy, I think. Okay, let's see the one in the book. I left for you this one, right? Okay, let's understand what is going on. First of all, x and y. I should do 3x and y. The first transformation is a what? Since 3 is multiplied with x, so this is a horizontal stretch by factor of what? Of 3. Okay, how can I find these numbers? First of all, I have to find the coordinates of A, B, and C. As we said, beginning by A, B, and C, we found the coordinates. And then, for the first thing, I should multiply the values of A by 3 and the values of x by 3, and y will remain as it is. And then I should multiply x by half and should multiply y by negative half. So you will be having A prime, B prime, C prime coming from the first transformation, and then A double prime, B double prime, C double prime coming from the second transformation. The way of doing this I showed you yesterday in the video. So please go back to your video and see what was going on. We did it together, totally. Okay, and then number, yes, number 11 and 12 was left for you as well. This was number 11. We can do it in the online thing. Okay, in here. In here. Let's see it. It was a very, very slight difference. Here, instead of 4, the book have a 3. But the same idea. Okay, first of all, I have to find the coordinates of A, B, and C. And then I have to subtract 1 from X and Y. And then I have to multiply X by 4 and Y as it is. And then I have to reflect the signs of X and Y, both X and Y. You will be having an answer like this. Again, how did we do it? We found the coordinates of A, B, C, like here. If you find the coordinates, I have to put the coordinates first. So A is, and then I will go and find A. What is the value of A? A was 2 and 2. And then I will write 2 and 2. So A is 2 and 2. And then I have to go find B. B is 2 and 5. 2 and 5. C is 3 and 2. Okay. So here, this is 2 and 5. C is 3 and 2. And then what should I do? Let's see. The first transformation we're required to do is to subtract 1 from each, X and Y. So this is what we are going to do. Let's do it. So here it's going to be 2 minus 1 is 1. 1 and 1. Here it's going to be 1 and 4. And here it's going to be 2 and 1. And then what should I do with these? I should go and grab them. Just go and grab them. This is going to be A prime, B prime, and C prime, which is going to give you this shape. This will be your shape. The first one, A prime, B prime, and C prime. And then I have to multiply X by 3. Okay, let's do it. Let's multiply X by 3. As if in here, okay? So it's going to be 1 multiply 3 is 3 and 1. And then 3 and 4. And then 3 multiply 2 is 6 and 1 as it is. So this is A double prime, B double prime, and C double prime. Again, just take them and go and grab them, and you will be ending with a shape like this. This will be your shape. A double prime, B double prime, and C double prime. And then the last thing, I have to divide, or I have to subtract X, not subtract, sorry, change the sign of X and Y. I have to go and change the sign of X and Y. Let's go and change the sign of here. So it is going to be -3 and -1. And then -3 and -4. And then -6 and, sorry, -3 and -4. And then here, -6 and -1. And then what should you do? You should take all of these points and go grab them. A triple prime, B triple prime, and C triple prime. Go and grab them, and then you will be ending with a shape like this. So this will be your shape in the end. A double prime, B double prime, A triple prime, and C triple prime. In the same way, you are going to do question 12, and this will be your model answer. Okay? Okay. Okay, let's start in the new lesson, lesson 18.2, proving figures are congruent using rigid motions. We said, what is congruent? Congruent means two figures having the same everything, equal length, equal angles, same figure, same everything. Congruent means same everything. And congruent figures come from rigid motion. If you are doing dilation, the two figures are going to be congruent? Of course not, because the size is going to be different. Either one of them is bigger or one of them is smaller. So congruent only comes when you are doing a rigid motion. Yani if you are doing translation, so the two figures are congruent. If you are doing a rotation, the two figures are congruent. If you are doing a reflection, the two figures are congruent. And congruent means that, you see the beginning here, two plane figures are congruent if and only if one can be obtained from the other by a sequence of rigid motion. Yani it means what? If one figure can come from the second figure using reflection or rotation or translation, then these two figures are congruent. Same size, same length, same angles. Okay? Okay. Let's see question 8. Where are we, by the way? We are in page 897. Page 897. Okay, can you see these two figures? A, B, C, D, E, A, B, C, D, and E, F, G, H. It's very obvious that they are very, very much alike. They are congruent. Same shape, same size, same angle, same length. Even if you try to get a ruler and measure them, it will give you the same answer actually. They are the same thing, everything. Trace planter ABCD, describe a transformation you can use to move the tracing paper so that planter ABCD is mapped into this planter. Yani, what is this? Most of the lesson today is going to be to prove that two figures are congruent. You have to tell me, is there a sequence of transformation, rotation or reflection or translation that I can do so that I can get one figure from the other? Can you try to tell me what happened for ABCD to obtain EFGH? Yani, did we do rotation? Did we do reflection? Or did we do translation? Or did we do one of each? Remember, girls, reflection, yani you are seeing something in the mirror. Yani, I'm not going to be having the same orientation. I'm going to be having as if you are seeing something in the mirror. Everything is reversed. Is there a reverse in here? No. Rotation, you have to rotate. Yani A, B, C, D is not going to be the same shape. The orientation will change, either going clockwise or counterclockwise. Did this happen in here? No, it didn't. So what happened here? It's very obvious. It's only translation. Only translation. Translation is very, very easy to see and to spot. When you have a translation, the shape will be the same, just different place. The same. A is in the place of A, B is in the place of B, C is in the place of C, and D is in the place of D. Just different places. So we understand it's a translation. Who can tell me how many points of translation? To find the translation, you have to specify a point and trace it. For example, I'm going to trace A. A became what? Became E. Let's count. 1, 2, 3, 4. So 4 down. And 1, 2, 3, 4. And 4 right. So this is what we did. I moved 4 down and 4 left. So what happened here? I translated 4 down and 4 left. So this is what we are going to be writing in question A. In question A, you have to write, this is page 897. Question A is translation 4 units down and 4 units right. Okay. Okay. Let's go and see question B. But before I ask you, translation is rigid or not? It's rigid. So these two figures are congruent or not? They are congruent. Since translation only happened and this is a rigid motion, those are congruent. So let's see what about these two figures. What do you think? What happened? Did I do translation? the orientation is not the same. Take care. The orientation is not the same. They are facing each other. Yani K is facing P, and L is facing Q, and J is facing N, and M is facing R. So this is what happened here. This is like what? As if you are seeing what in what? As if you are seeing what? What if a mirror was put in here? So this will be what? A reflection. Those are actually a reflection of each other. Those are a reflection of each other, but not across X or across Y. Across Y equal X. You remember Y equal X, the line that is passing in here? So this is actually what happened. A reflection happened here. So this is what we are going to write in here. So it's a reflection. So for question B, what happened? Reflection. We can write across Y equal X. Okay? Reflection is rigid or non-rigid? Again, it's rigid. So my figures are congruent or not? They are congruent. Question C. What do you think is happening in here? Very obvious. It is a what? It's a dilation, right? It's a dilation. Shrinking or stretching? It's a stretch, right? By factor of what? If I need to find the factor, how can I find the factor? To find the factor, you have to find the scale factor by dividing the new length by the old length. But this is not our question now. The question is determine whether the lawns are congruent. Are they congruent? Of course not, because the size are different. Is there a rigid transformation that maps this to this? Yani, can I do translation and this will happen? No. Can I do rotation? No. Can I do reflection? No. So what does this confirm about the lawns? That they are not what? They are not congruent, because there is no rigid motion that I can do to get one of the other. So this is what we are going to do. Or to write in question C, they are not congruent. Not congruent. Just like this. Okay, going to reflect one. Okay. Reflect one is saying, how do the size of the pairs of figures help determine if they are congruent? If the size are the same, so they are what? Congruent. If the size is the same, so they are congruent. So this is what we are going to write in here for question 1. If they have same size, they are congruent. Okay. Okay, let's go back to our book and let's go to the second page. Yes, determining if figures are congruent. Today we are going to be having two concepts. So let's start with the first concept. Use the definition of congruence to decide whether the two figures are congruent or no, and explain your answer. We said two figures are congruent if what can happen? If there is a sequence of rigid transformation, reflection or rotation or translation that I can do so that I can map one figure to the other. Okay, let's read question A. Can you see these two figures? Can you tell me if they are congruent or not? How can I tell you? If I tell you that I can do reflection or translation or rotation, so they are going to be congruent. What do you think? What's happening here? They are doing what? It's very obvious. They are doing reflection. It's a reflection, right? L is facing E, M is facing F, J is facing C, and K is facing D. So it's a reflection. The two figures appear to be the same size and shape. So look for a rigid transformation that will map. You can map CBDE to whatever by reflecting over y-axis. The reflection is a rigid motion, right? So the two figures are congruent. And the coordinate notation is, how did he know this? Using the tables. You remember in module 17, the tables that we learned about rotation and reflection? And we said it's very important for you to understand and to a little bit not memorize, just understand and use and write it by your own hands, not to forget them. Let's try to do question B together. The two figures appear to be same or different size. I don't know. Let's try to count. Here, this is 1, 2, 3, and this is 1, 2, 3. So actually, yes, they are the same size. So they are the same size. But I'm going to choose same here. They are the same size. So I can map them by what? What do you think? Which transformation is happening here? Translation, rotation, or reflection? Is it translation? Of course not, because they are not having the same orientation. Is it reflection? At all. Nothing is facing nothing. So this is not reflection. So I am having a rotation. Rotation can be 90, 180, or 270. And the rotation, to understand how many degrees in rotation, trace a point and see this point moved 1 quad, or 2 quad, or 3 quad. The point B is similar to which point in here? Similar to point Y, right? Point B was in quad 1 and it moved into quad 2. How many quads it moved? 1 quad. So this is how many degree? It's a 90 degree. Counter or clockwise? Counterclockwise. So this is what you are going to be writing in here. In here, we are going to write 90 degree counterclockwise. 90 degree counterclockwise. Rotation first of all طبعا. By rotation, 90 degree counterclockwise. Rotation 90 degree counterclockwise. So this is or is not a rigid motion. This is a rigid motion. So the two figures are or are not congruent. They are congruent. The coordinate notation for the rotation is 90 degree counterclockwise. How can I put the notation? Go back to the book. Go back to lesson 17.3. It's going to be x and y are negative y and x. X and y are negative y and x. This is what you are going to be writing here, the notation. X and y, arrow, negative y and x. Okay? Okay, I will leave question 2 and 3 for you. You have to try to do it by yourself. It's very easy here. What's happening? You have to tell me a sentence like this. The question is asking about a sentence like this. The two figures appear to be, and then you tell me same or a different size, and this can be mapped by, tell me which kind of transformation happening, and this is is not a rigid motion, so the two figures are or are not congruent, and then write for me the coordinate notation. Yani this sentence, all of this should be written once in here and in here, according back to the transformation happening. I will give you a hint in here about number 3. Number 3 actually is not one transformation. Okay? Actually, it's 2. And you are starting by this one. I did something in here and then I moved. Yani just as a hint, actually, it's going to be a reflection, then a translation. You tell me how reflection across what and translation how many points. And I will give you the correct answers, inshallah, on Sunday. So number 2 and number 3. Okay? Okay, let's go to the second part. Finding a sequence of rigid motions. The figures shown are congruent. Here he is telling you they are already congruent. Here he was asking, use the definition of congruence to decide are they are congruent or not. Yani here he is asking you, are they congruent or not? Here he is telling you they are already congruent, and you have to tell me what is the sequence of transformation happening so that I can map one to the other. And by the way, this thingy in here, because we are going to be seeing a lot of this starting from now. This thing is means congruent. When I tell you that triangle ABC and then I put this mark to triangle PQR, it means that triangle ABC is congruent to triangle PQR. These two lines and this mark is congruent. Okay? So if triangle ABC was congruent to triangle PQR, who can tell me how can I change one to the other? It's written already. Actually, it can happen in more than one way. Here he is telling you, first of all, I did a rotation of 180 degrees around the origin. For me, I thought it was actually not a rotation, it was a reflection across y equal to negative x. This line, you remember the line coming from here to here in the middle? It is the same idea. So it was, I'm going to write a reflection across y equal to negative x. But the problem is, try back to focus with me, and I will increase B here. Yes, try to concentrate with me. If I did this reflection or the rotation, they are the same thing. Point C will actually land in here, exactly in here, but it didn't. It is there. Point B is going to be exactly in the middle, in here, but it didn't. It went there. Point A should be exactly in 8, but it didn't. It went to 9. So what happened? What did I do? After reflection, I did a translation. Point C should have landed in here. It didn't go up or down. It went right. How many points? 1 point to the right. So I can say that after rotation or reflection, you can write whatever you want. I did a translation. By how many units? 1 unit to the right. And Y was left as it is. That's why I mapped triangle with a rotation of 180 degree around the origin, or the reflection that we said. And after doing this reflection, actually no, it cannot be reflection, by the way. It's not a reflection by y equal to negative x, as we said. No, it's only rotation, because if you did reflection, the point A will not land here. Point A will land up here. If I do reflection across y equal to negative x, as I was saying, the triangle will not be landing in the same way. Point B will not be there. It will be in a place in here. So actually, no, this is only rotation. It cannot be a reflection across y equal to negative x. It's not a reflection, no. It's not a reflection. It can only be, so it can only be a rotation, because you remember reflection was across y equal to negative x, means that x and y is going to be negative y and negative x. So of course it will not land the same. If I did a reflection, point A will not be there. It will be up here. So of course this is not a reflection at all. This is only rotation 180 degree around the origin. It's only a rotation 180 degree around the origin. Okay, after doing the rotation, I have to do a translation. Okay, let's think about question B. What's happening in question B? Map triangle ABCD with a what followed by a what? And he is helping you. We did two things in here. Is the orientation the same of the two figures? Of course, the orientation is not the same. The orientation changed. I will give you a hint. What happened and then what happened? What if I get my figure and I moved it down in here, and then I reflect it? it will give you the same figure. Look, BA is exactly in the middle, So what if I try to put it exactly in the middle, like in here, and then I reflect it? It will give you the same figure. So triangle or the quadrilateral BABCD, first of all, it moved down to be facing this, and then it moved a little bit to the left, and then I did a reflection. Let's see the answers in here. There. Look in here, girls. First of all, I was thinking that I'm going to do a translation and then a reflection. He started by reflecting and then translating. It is the same idea and it will give you the same answer. So let's think about my answer. Let's think. I wanted to do what? I wanted to make them move down. Yani I want A to move down to face to be in here. And then I wanted it to move a little bit left. So let's count. How many points down? 1, 2, because this is a 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be moving down 10 units. So y minus 10. And I want it to move left. How many points? 2 points, because I want it to be exactly in the middle so that when I reflect it, it will be exactly facing here. So what I was going to write, how can I do the answer for here? I was going to write that, first of all, translation, it was going to be x and y is going to be x minus 2 because I'm moving 2 units left, and y minus 10 because I'm moving 10 units down. After doing this, I'm going to do a reflection across y-axis because I want the mirror to be y-axis. The reflection across y-axis means that x and y is going to be put negative to the other side, so negative x and y. So this is my sequence of transformation. Will it give me the same answers as the book? Yes, it will give you the same answers as the book. Why did I contradicted the book? Because I want to tell you that actually the solutions of the book is not conclusive or is not exclusive. Actually, the sequence of transformation, each one of you can have a different idea. You can think about rotation and then reflection. She can think about reflection instead of rotation. The other one can think about translation that happens first and then whatever. Yani each one of us can have a different idea and all of us will land to the same answer. In the book, he started with reflection, yani he did reflection first, and then he did translation. It is the same idea. If we get the same answer, so it's okay. Understood? Okay. I will leave for you question. Your turn. Yani you have to do your turn by yourself. These two questions, question 5 and 6. Okay, just question 5 and 6. Okay, the last part that we have, it's a very, very small part, which is in page 900. Very, very, very small part. Instead of having figures, he is giving you angles and segments and telling you, determine which angles are segments are congruent and describe the transformation that can be used. Can you see angle A? Can you see angle B? And can you see angle C? Which of them is congruent to the other? Angle A and angle C. They are congruent. They seems to be congruent. You can go get your protractor and measure the two angles. You will find that angle A exactly like angle C. So how can I get angle A to angle C? Only what? Translation. There is no transformation that maps angle B to either one of the angles. That's why angle A and angle C are congruent by translation. What about the segments? What? AB is congruent to which segment? Go get your ruler, measure these two, E, F, and CD. You will find that actually CD is so similar to AB. EF is bigger. So AB and CD are congruent. AB and CD are congruent. A sequence of transformation is a what? How can I map AB to CD? I think AB, since it's changing orientation, yani A is looking to C, so as if I did a reflection and then I did a translation. So this is what we are going to write, is a reflection and a translation. Reflection and a translation. There is no transformation that maps what to either of the other segments. There is nothing that maps EF to one of the other segments. So just write A and B. يعني question B, here we wrote A, B, C, D. يعني here we wrote C, D, and then is a reflection, and then here EF. And then try to do question 7. In question 7, just tell me which two segments are similar to which and which angles are similar to which. And that's it. I don't need to for you to write for me the transformation that maps what to. Okay? Okay, the lesson is done. Please be aware with the questions that I'm going to write for you on Class Dojo post. And thank you, and I hope for you, inshallah, a good weekend. Thank you.